geometric application. So it just says depreciation is the reduction in value. A used car is not worth as much. Usually you describe it as a 15% loss. So we're going to kind of not do it year by year because we already talked about last class the shortcut for doing a depreciation calculation because it was on the last work that we did. So this just says if he bought a used truck from a friend, paid $10,000, the rate of depreciation is 15%. How much is the truck worth 1 year later? What do I want to multiply by? I don't want to multiply by 15%. That gives me just the loss. So I want to multiply by 85% because that's the worth of the truck after 1 year. So all we have to do is take the $10,000. You have to realize which percent to use. I think that's the only, challenge of this is I want to use 85% because that's the current value of the truck after it has depreciated. So you'd be at $8,500. And then number 2 is basically talking about that. What's another way to calculate 15% loss in one step without having to subtract the 15% loss? So instead of multiplying by the 15% and subtracting it, we're kind of already more sophisticated and we already know how to do number 2. So they want you to show the value of the truck. Like we know that it's 10,000 to start with, and then it's 8,500. So you could just use your calculator's table if you want. You could plug into the y equals menu 10,000 times 0.85 to the x power. That way x will be like 1 year, 2 years, 3 years. You don't have to do x minus 1. They already kind of have 10,000 at year 0. So you can fill in the rest of the table. There's the expression that I kind of already wrote for you on number 4. And then they want you to do the value of the truck after 15 years. So see if you can fill in the table, do the value of the truck after 15 years. You can plot the graph on the back page. And then there's like 3 extra questions about depreciation. Just to kind of give you the idea that this is going to look like an exponential curve and practicing this geometric application. So fill in your table and you can go right on to the back and finish the rest. So here are the answers to the car depreciation problem in case you want to check your answers. And on the back page, we observed that it looks like an exponential decay graph. And you'll really want to try these practice problems at the bottom because those are similar to what you might see on the quiz or the test. So I'm going to scroll down and show the answers, but you probably want to try them on your own first to make sure you know how to do them.